Hi. Again, before us here, we have this question before us here. The question says x plus y equal to 4 is given as equation 1, and xy equal to 9 all over 2 is given as equation 2. Then what is the value of x, y that will satisfy this equation, the pair of x and y that will satisfy this equation? So let's go into this solving without much waste of time. So here we're taking a solution. The first thing to do, okay, now if we look at these two equations here, what we want to do here is easy. We want to make y the subject of the formula from equation 2. So from equation 2, make y the subject of the formula. So let's put it and write it from equation 2, make y subject of the formula. Okay, make y the subject of the formula. So this is going to give us here y will now be equal to our 9 all over 2x. Easy, right? Okay, so let's give this as equation 3. Let's give this equation 3. So we want to put equation 3 into equation 1. So put equation 3, let's put it here, put equation 3 into equation 1. Look at our equation 1. Let's simply bring it down. So we have here x plus y equal to 4. So wherever we see, we want to put in our 9 all over 2x into it. So this is going to give us our x here plus our 9 all over 2x equal to 4. Yeah, look at what we have here. We want to eliminate this denominator. So we want to multiply both sides of the equation, or multiply all the quantities in this equation by 2x. Yeah. So this will give us here our x times 2x. Let's put it in bracket, plus our 9 all over 2x times 2x. This is equal to 4 times 2x also. So we know this will leave the system. So we're now left with 2x to the power of 2 plus our 9. This is equal to 8x. Rearrange it, this will give us our 2x to the power of 2, then minus 8x plus 9 equal to 0. Okay, so we continue on this side here. Now this is a quadratic equation, so we want to solve this quadratically. Can we use factorization method? No. So let's use the formula method to solve this. So from here we can say using the formula method, using the formula method. Yeah. So we have this to be our x will now be equal to minus b plus minus the square root of b squared minus 4ac, everything all over 2a. So what is our a, b, and c according to this equation? We have our a is equal to 2, then our b is equal to the coefficient of x, which is minus 8. So we have here minus 8, and our c is equal to plus 9. So we have here 9. So substituting, we're going to have our x is equal to minus bracket minus 8 plus minus the square root of our minus 8 r to the power of 2 minus 4 into 2, then into our 9, close bracket, everything all over 2 into 2. Okay, so this will now give us x is equals to minus times minus will give us plus. So we have here 8 plus minus the square root of minus 8 to the power of 2 will give us 64. So we have here 64. Then minus 4 times 2 will give us 8. 8 times 9 will give us 72. So we have this to be 72. All right, everything all over 4. Good. So 64 minus 72, that will give us minus 8, right? So we're going to have this to be 8 plus minus the square root of minus 8 all over our 4. We can rewrite this square root of minus 8. Okay? So rewriting this is going to give us our 8 plus minus the square root of minus 1 times the square root of 4 times the square root of 2 all over 4. If you have a sound knowledge of solve, you discover that whatever we have here is true. Or we put this together, it will give us this here. Now, we know that the square root of minus 1 is equal to iota, right? Recall that our square root of minus 1 is equal to iota. We know this, right? Okay, so if we are acquainted with this, so we can bring in iota here, and this is a perfect square. So the square root of 4 automatically will give us 2. So we can rewrite the whole of this expression here to give us here our x. Let's bring it down here. This is equal to our 8 plus minus 2i there into the square root of 2 all over 4. Let's continue on this side here. So from here, we can rewrite this expression here. So this will give us here, because here we know that 4 can go into 8 completely. So let's go ahead and rewrite this. So we're going to have our x is equal to our 8 all over 4, there plus minus our 2i into the square root of 2 all over 4. So if we divide down, we're going to have our x is equal to this here 1 here, 2. So this is going to give us 2. Plus minus 2 here will give us 2, 2 here will give us 1. So we're going to have I into the square root of 2 all over our 2 in here. Okay, so we have 2 roots from here. Now, what are the 2 roots? So we have our x1 is equal to our 2 plus square root of 2i all over 2. And our x2 is equal to the 2 here minus the square root of 2 the I all over our 2 in here. So these are the values of our x that will satisfy the original equation. Now we have a corresponding value for our y that we when we multiply together we give us this, or we add this together will give us this. So how do we solve for that value? It is easy. Let's go back and see where we made y the subject of the formula in our initial stage. Here, look at equation 3. So from equation 3, we want to solve for our y. So can I call yourself from equation 3? So we're going to have, let's bring down our equation 3. We have y is equal to our 9 all over 2x. So wherever we see x, what do? We put in the value of x1. So automatically we're looking for our y1. Okay? So this will give us our x1. So we have here y1 will now be equal to our 9 all over 2 into everything here. We have 2 there plus our square root of 2i there all over 2. Close bracket. Put this way. Okay. All we just need to do is just to use this to open up everything we have in here, right? So let's open up this and see what this gives us. Let's continue on this side of the board again. So from here, we said let's use this to open this now. So this is going to give us our y1 is equal to, we have our 9 here all over. This times this will give us our 4 there plus. Then we use this to also times this will give us 2 into the square root of 2 into our I, then all over 2. So what do you observe from here now? This we go with this, right? So we now have this to be our 9 all over 4 plus the square root of 2i. Now let's look at this carefully. We have to rationalize the denominator here. If you are familiar with solve, how do we rationalize this denominator? We look for the conjugate of this. And what is the conjugate of this? It will be 4 minus 2 root I, right? So this is going to give us here, so we can say here, say rationalize denominator. Okay, denominator here. So this is going to give us our y1 is equal to 9. The conjugate is 4 minus the square root of 2i, close bracket, everything all over our 4 there plus the square root of 2 iota, then close bracket, bracket 4, then minus square root of 2 iota. Okay? All right. So this is going to give us here, let's keep our 9 to the power, sorry, or to 4, then minus square root of 2, the I here. All over what happened? Because we have multiplied this by its own conjugate. So this is what will happen. We're going to take the square of this minus the square of this. So this is going to give us here 4 to the power of 2, then minus the square root of 2i all to the power of 2. Very easy, right? Good. So this is going to give us here, we have our 9 into 4 minus the square root of 2 iota, then all over, you're going to give us here 16 minus, if we take the square of I, which is our iota, that will give us minus 1. Why? Because we know that the square root of minus 1 is equal to iota. So if I square this and also square this, what happens? This will leave. So we're going to have minus 1 is equal to iota square. So the square of iota will give us minus 1. So this square, this will cancel out this. Okay, even at this one, affect this like this. And so we're going to have minus 1 from here. So minus 1 times 2 will give us minus 2. So minus times minus here is going to give us here plus. So here we're going to have plus 2. Easy. So let's continue on this other side. Mind you, we started from here back. Yeah, we're moving backward. And yeah, let's go back to this side now. All right. So this is going to give us our y1 is equal to 9 bracket our 4 minus square root of 2i close bracket all over 16 plus 2 will give us 18. Something can go into this 9 here 1, 9 here we have 2. So therefore we have our y1 is equal to going to give us 4. So we're going to have 4 all over 2 minus square root of 2 iota all over 2. Again, this will give us 1, this will give us 2. So we now have, therefore, our y1 is equal to our 2 minus the square root of 2i all over 2. Now, if we do this for our x2 to get our y2, we're going to have our y2 to be y2 will automatically be our 2 plus our square root of 2i all over 2. So these are the value of our x1 and y1. Okay, this for x1, s2, then y1, y2. So you discover that the 2 or the 4 roots here, the pairs are kind of conjugate. Okay, look at our x1. This is x1. It's same thing with our y1. The only difference is that this one is a minus, while this one is a plus. So this is a conjugate of this. If you go to our x2, the same thing. This is a conjugate of this. Okay, so let's go ahead and bring out the pairs of solutions that actually satisfy this equation here now. Okay, so let's erase this side. So the actual pairs of x, y that will satisfy this original equation is going to give us our x1. So we have here 2 plus our square root of 2i all over 2, comma, then our y1 we have 2 minus the square root of 2i all over our 2. Okay, then our x2 we have 2 minus the square root of 2i all over 2, comma, our y2 we have 2 plus the square root of 2i all over 2. Okay, so these are the pairs. And if we put this into either equation 1 or equation 2, you discover that they will both satisfy the equation. All right, so this brings us to the end of this class. If you learned something from this video, do not forget to give the video a thumbs up, and also do not forget to share with friends and family. Okay, if you have any question with regards to this challenge, drop it in the comment section. We'll reply to your question or your comment. Thanks for being there for OnlineMathsTV. We love you dearly. Thanks once again. Bye. We meet you in our next video or in our next class. Keep winning. Bye for now.